right, last piece for Unit 4.3 exponential functions is it's just giving you a chance to utilize an exponential function in a real life scenario. And so when we do this, and this is very basic in its approach, when we do this, what we have is we have basically 4 variables. And so let's go ahead and define what these variables stand for. So A stands for what we call our future value, like what we're going to get in the future of what's happening here. P is called P naught, or P sub 0 as read in science, is called your initial value. R is your rate, which is basically your percent, and T is your time, of course. So when I approach one of these questions, what I like to do is I like to say, okay, well, I need to know an A, a P naught, an R, and a T to be able to plug this into my formula. So I read the question and see if I can come up with those things. So right here we read off, it says the initial population was 15,000. Well, we know P naught is initial population, so we got 15,000. It has a growth rate of 15%. There we are, percent, that's my rate. And how many would you have after 4 years? Well, that sounds like 4 years is time. And so the question is, it says, how many will you have? That's a future thing. How many will you have in the future? So this is what we're looking for. So we take our formula. A is equal to P naught 1 plus R raised to the T. And one thing that we do here is that we have to change the percent to a decimal. We've got to take that decimal and move it over 2 times, because percents are out of 100 and we get 0.15. So when we plug in, we get A is equal to 15,000, 1 plus 0.15 raised to the 4th power. So you just grab your calculator, pull that guy out, go to your home screen, second mode, clear that off, and just plug it in. So 15 grand, open parentheses, 1 plus 0.115 raised to the 4th power. Bam. So there's my future population. Please pay attention. In my math lab, they're going to ask you to round a particular number. Here I'm just going to round to the nearest whole. We're talking about the number of deer. So 26,235 deer would be my future value. And that's what's going on for these problems. So play around with that. That's the last little piece of the homework for 4.3, utilizing exponential functions in a real life application.